engancharle el ordenador a alguien. Vale. Dejo ahí el mando. Para controlar la imagen.
Ahí está Andrew.
Hello.
Hello.
Nice to meet you. Nice to see you.
You're wearing the same jacket. Is this okay with the laptop? Yeah?
Yes, it's okay.
Good. Yeah. Oh, thank you.
Bueno, yo en primer lugar, antes de continuar, presentarme. Buenos días a todos, mi nombre es Almudena Majano, soy profesora aquí en la Escuela de Arquitectura y también miembro del comité organizador de CIMAD. En primer lugar, quisiera darles también la bienvenida a Madrid. Estoy realmente muy feliz de poder compartir estos días de congreso con ustedes, un congreso que toda la organización hemos organizado con muchísima ilusión y deseo de corazón que disfruten enormemente. Darles mi agradecimiento por su asistencia y por su participación. Y a continuación pues vamos a comenzar ya con la primera ponencia de apertura, cuyo ponente me van a permitir que presente en inglés. It is my honor to introduce our distinguished speaker today, Mr. Andrew Waugh, a founding director of Waugh Thistleton Architects, a practice committed to creating beautiful buildings and places that acknowledge their environmental impact. Mr. Waugh is a globally recognized spokesperson for low-carbon architecture and innovative construction, and an international advocate for the urgent need for change to mitigate the climate crisis. Andrew serves on the steering committee for Architects Declare and is a senior fellow for Architecture 2030, pushing for a green transition in the construction sector. Andrew's innovative approach to design has been acknowledged by many prestigious awards, including the RIVA President Award for Research, a Stirling Prize nomination in 2018, and the recent UK Practice of the Year Award for 2030. So please join me in welcoming Mr. Andrew Waugh with the keynote title, An Architecture of Sufficiency. So Mr. Waugh, please, the floor is yours. Thank you.
Buenos días. Lamento hablar inglés. So thank you very much for coming. So this is us, we're Waugh Thistleton Architects. That's me, I'm the oldest. We've been working as a practice about 24 years, and I suppose for the last 20 years, the focus of the practice has been increasingly around climate change. Has been increasingly around understanding the impact of construction and therefore architecture on the environment, on our planet. And when we talk about these things, we often talk about it in terms of numbers, and we talk about it in terms of targets, or we talk about it in terms of BREEAM or LEED or any of these types of certification. But actually, I think it's really important to just acknowledge, to think about the fact that climate change is here and now. It's not something in the future that might happen to us. Climate change is here and now, and climate change is Donald Trump, and climate change is Brexit, and climate change is mass migration, and climate change is heat waves or freak storms or all these things. This is happening now. And as architects, as developers, as government officials, as contractors, as manufacturers, as all of us, the responsibility for all of us to ensure that our actions are ones that help to solve this problem, that help to mitigate this issue, rather than to exaggerate it or exacerbate it, I think is imperative on all of us. And so the work that we do, we constantly are acknowledging and thinking about what the impact of our work will be on the climate. And, you know, this isn't a new conversation. In the 1970s, people were having this conversation, and it was about operational carbon. It was about the heating and the cooling, the lighting of our homes, of our offices, of our schools. And you can see that in the 70s, the vast majority of carbon for a building's lifetime of 60 years, normally 60 years, that the vast amount of carbon created by that building was the operational carbon. And we got pretty good at actually reducing this with double glazing and insulation and really beginning just to think about these sorts of issues. And by the 2000s, this had actually sunk right down to becoming about a third of a building's carbon footprint. And so in the 2000s, we began to think about, where does our energy come from? You know, and so we put solar panels on the roof, we put a windmill outside, we had geothermal, we had all these ways of creating energy, which really are low-hanging fruit. And all these things have allowed us to continue in the same way without any real major change. But where we are now, in the 2020s, when we've got good at solar panels and good at windmills, means that actually the vast majority of the carbon of a building's lifetime is the materials and the construction process. And so, as members of this industry, what we need to be looking at is actually this burden. And this now in Europe is nudging towards 25% of our greenhouse gas emissions are caused by construction and the materials that we use for construction. And so this is really, at the moment in Europe, completely unregulated. This doesn't have any laws. There's a little law in Denmark that says that you should take some notice of it. You know, there's a law in Ireland that says that you should tell them the numbers of the embodied carbon. But actually, this is something that's been very slow to emerge. And that's, you know, for lots of reasons. And you can see because there's a lot of money in construction. This is the Bloomberg building, not by us, by Norman Foster, Sir Lord Foster. And this building won the Sterling Prize in 2018. And it won the prize because of sustainability. Because they spent 100 million euros to push themselves above building regulations, beyond what was necessary. They spent 100 million euros. In fact, somebody at Foster's told me that each one of these fins here costs the same as a Maserati sports car and has a higher carbon footprint. In fact, the 100 million pounds that they spent on this building, on these systems, on really complex air movement, handling systems, monitoring people, monitoring the air conditions outside and inside. Of this 100 million pounds, the service engineer told me that if they put a poster up outside the front door, and in the summertime the poster said, "Take your jacket off," and in the wintertime the poster said, "Put a sweater on." He said if they put that poster up outside the building, they could have saved 100 million pounds. And so the reason why I talk about this is actually just to address the problem that we have, which is at the moment everything about reducing our impact on the climate is all about an additive process. It's all about putting more stuff on, doing the same thing, but putting more stuff on top of it. And what we need to be doing, we think, is to step back from this, to think more carefully about how we see success in architecture, to think about how we gauge a building's success, how we feel successful as architects, and to think more carefully about that, and to think more carefully about that not being an additive process, but being more conscious about the building materials that we use and where we think that our buildings have succeeded, where we think that they're successful, and perhaps start thinking more about the people that use those buildings rather than the people that designed them. And so in 2008, we've been thinking about this for a while, and in 2003, we built our first CLT building. A little building, 40 square meters. We dropped it into the backyard of an existing building in central London, and it was fantastic. It was a beautiful process. It was amazing. It was millimeter perfect. The whole building was built on a Saturday afternoon, and it was wonderful. And after that, we built a couple of small buildings from CLT, but we had in the back of our mind, or the kind of, the conversation in the office around this idea that this complex issue that you have with increased urbanization, a need for dense housing, dense urban housing, and at the same time, understanding that the concrete and the steel that was going to make this housing would exacerbate the problem of climate change. And so how could we find a viable alternative for concrete and steel in high density, high-rise housing? And so in 2008, we were fortunate enough to get this project in just near our office in London. And the entire building, 9 stories high, is made of timber. So there's timber lift shafts, timber staircase, timber walls, timber floor, timber roof. And you can see really quite simple construction. 4 people built the entire structure in 27 days. The whole building goes together with a 7-centimeter bracket and a 12-centimeter screw. So very fast, no power tools, no cement mixers, no grinders, no axes, no massive noise. Very quiet, very fast, very simple process. Far less waste because it's all prefabricated. So no massive trucks coming through the city all day long. So fewer deliveries because of the prefabrication. And lightweight. It weighs 1/5 of a concrete structure. So the reduced foundations, and then again reduced materials coming into the center of the city. And so we were so excited about what we'd done, we wrote a book about it. And this has become really quite an important part of our practice, because we we had a lot of interest in the building when it was going up, and we thought to ourselves, well, the reason that we've done this is not through any personal or individual sense of achievement, but because we think that this is the way that everybody should build. This is something that all architects, all contractors, developers should be involved in. And so we decided at that point that we would share all our work, and that we would talk about our work whenever we had the opportunity, that we would share our drawings, that we would share our technology, and that we would be evangelical about the opportunities of building in timber. And so this book is still online, it's still available at Amazon. I get 10 cents. So, and then in 2012, we built a couple more buildings by then, and in 2012, I sold my apartment, I sold my car, one of my children, and we, and with 2 friends, Dan and Nicola and Jason and Laurie, we bought this piece of land in Shoreditch. And when we bought the piece of land, we got the planning consent, and we had 4 floors of offices and then 3 homes, so 3 stories homes. And we built this, and if you remember this building here, this is like a honeycomb. All the walls, all the floors, everything is working really tightly together. To live on the top, obviously. We use the party walls, so the walls between each one of the flats, we use those as beams that supported the floors going this way, and then those beams tied into the front elevation and the rear elevation, which acted as a giant truss. Does that make sense? So they're kind of like, so the front and the rear elevations working like this, and the beams work between them, and then the floors span this way. So it's incredibly light and incredibly strong. And we're using the CLT not only as a wall, but also as a beam to carry the floors. And so what we've begun to do with this building, really for the first time, is to think about a different architecture that a different material provides. You know, 100 years ago, when we first started using contemporary reinforced concrete, it changed the nature of architecture. It changed from the architecture of the 19th century to a modernist architecture of the 20th century, with Corbusier and others actually by changing the construction material, that then informed the architecture that they proposed. And so we see the beginning of this happening as well with this technology. And so you can see this is the building going up. And again, instead of having big panels and cutting holes out of the panels, we're starting to use the material a lot more efficiently. The whole building, you know, Murray Grove, our first tall building, that was built, you know, that was drawn on tracing paper, and the engineering was done on a calculator. You know, 4 years later, this is all three-dimensional software, and we're taking the same software, it's going from our computer, it's going to the engineer, it's going to the factory. So it's a completely different process, a completely different way of designing, of calculating, of manufacturing and construction. And that's it, just before I left. It was actually sunny in London when I left. And so we've completed now 30 buildings in the UK and France. This is the biggest completed project. It's 20,000 square meters in North London, a residential tower. And it would have weighed 10,000 tons in concrete. 10,000 tons of concrete coming into central London. But in timber, weighs less than 2,000 tons. So it's incredibly lightweight. This is dense housing. So here what we've done as well is to begin to understand the way that the material works in terms of height and in terms of density. So if you remember, when we first got this project, it was there was a planning consent on the site for 3 towers, about 15 stories high, in a row, 1, 2, 3. Now you can't do that in timber. It just doesn't work. Tall, thin buildings in timber don't work, because the timber is so light that you're always thinking, when you're building in timber, you're not thinking about how you hold it up, you're thinking about how it will blow over. So the shear forces, the horizontal forces against it. And so what we've done here is to make a low, dense building that works with those forces in mind. And so now, you know, when you read Dezeen or you read any of these magazines and you see these super tall buildings made of timber, you know, colored in brown, and underneath it says timber building, so you know it's a timber building, they all have lots of concrete on the top floors to weigh the building down so that it doesn't move in the wind. So this building was finished in 2017, incredibly quickly. You can see how fast it was, because by the time the train has gone past, the building is finished. And we were in contact with other people in the UK who were building buildings from timber. And actually, you know, we got to the point where we're kind of like stalkers. You know, if we found out somebody else was building in timber, we'd call them up and say, hey, we hear you're building in timber, how's it going? You know, what are the challenges, what successes, what are you doing, how are you kind of like, where are you getting your timber from, who's the engineer? You know, and began to try and build this kind of community in the UK of people who were interested in doing this. And so after a couple of years, we had actually a large amount of information, drawings and photographs, interviews, and so we approached the US Department of Agriculture, and they paid us to put this together in a book. And this book is still available online for free. It's at thinkwood.com, and you can download this. This is a study of 100 projects across the UK. Some of them by us, but not 100. This is a project we completed in 2018. It's a factory building in the UK, and it's for this shelving manufacturer. And this shelving is a shelving system that is loved by architects. It's very simple, has these rails, and within these rails you can place components. Shelf, drawers, desk, and you can move these components around. You can take it down, you can take it to your next house, you can put it back up, you can change the use of it. And they said to us, what we want is a building that works in the same way. So that's a challenge, obviously. Architecture is a little bit different from furniture design. So we worked with them, designing this system where we have this very strong frame, and then to brace this frame, to hold the frame still, we put softwood CLT on the outside of the building. The inside of the building is using a hardwood LVL. So that's a veneer laminate. So like glue lam, but veneers, building in beams and columns. And it's incredibly strong, about 3 times stronger than concrete in compression. So with this lightweight, super strong frame, we then clad it with CLT on the top to give it that bracing. And you can see here the north lights here providing daylight inside the building here. And you can see this is the frame, the LVL frame. And we love LVL because the thing about a veneer is, you know, you get the trunk, you put it on a big spiralizer, and you spin it really fast, and out comes the veneer. And so you're using about 95% of the tree. So it's a really effective use of the material. This is made from beech trees in Germany, which are the second largest farmed tree in Central Europe. So a very efficient use of this material. In fact, most beech is burned. About 3/4 of beech trees that have felled is burned for biomass. So using this super strong material, you can see when we left the site, we left the client with some extra beams here and here, and the client built this themselves. So the client came, and if you see these slots here, the beams slot into here, and the client was able to build these little apartments, these temporary apartments, for people to live while they moved the factory. And here we also began to enjoy other things about building in timber. We began to enjoy the kind of the health and the well-being benefits of the material. We began to understand that actually being in a timber building is good for you. You know, people sleep better at night. They learn faster at school. They get better quicker in hospitals. They work longer hours in timber offices. These buildings make a difference to us. And of course, why wouldn't they? Because we know that actually, you know, healthy, natural things are good for us in our clothing, in our food. You know, why wouldn't this be the case in building materials? Why would you want to lie in a hospital bed and look at a polystyrene ceiling tile when you could be staring, you know, out the window, natural daylight, and looking at natural materials? It's so obvious that this is going to be so much better for you. And so we took this understanding, perhaps of the biophilic benefits of the component-based design, and this is how we've begun, I think, more recently to develop our architecture. And so here, this is the black and white building. This is a building finished about 18 months ago in central London, and it's a building for Blackstone. Blackstone, as I'm sure you know, a global investor. They told me when I first met them that they had a budget that was bigger than Belgium. Right? So this building is entirely made of timber from the ground floor up, 5,000 square meters of co-working space. And you can see again, we're using this lightweight LVL frame with the CLT floor slabs, CLT core. And one of the things that we've done here with this building is where the CLT floor slabs work is in order to brace this frame, what we've done is rather than sit the CLT slabs on top of the beams, we sit the CLT within the structure. We sit the CLT within the beam, and therefore we use the floor slabs to hold the building stiff, to brace the building. And by doing that, we're able to really reduce the amount of timber that we use in the building by about 25% from the first drawings to what was built on site. And you can see here, I don't know if you can see how that floor slab there is sitting within the beam. And also working on understanding what the grid should be, understanding what the span should be, understanding where the core is placed in order to provide that stability to use as little timber as possible. And that allows us also to be able to say to our clients, this costs the same as a concrete building, but it's 4 months faster to build. And so that really helped us in terms of our conversations with Blackstone. And so the other thing that we've done now is that we calculate the carbon implications of all of our design decisions. So we look at the carbon at stage 2, at stage 3, and before we start building, and then after we've built the building. So we make an analysis of different design decisions and what the implications of those decisions are. Now, if you think that in central London, an office building is usually around 1,000 kilos a square metre of carbon equivalent emissions, and we're at 300, so 329. So about a third of what a typical office building would be. And this building very much works with natural light, with natural materials. We have, as I think you can see on the outside of the building here, we have the solar shading on the outside of the building, which allows us to have completely clear glass into the building. And so you get a very different feel from a regular office building. You can also recycle the glass, which you can't if you put any coatings on the glass. So we have this clear glass, which begins to give a different kind of atmosphere to the building. You can see that it has a kind of domestic atmosphere to it. It has a much more human kind of feeling when you're in the building. And it's really simple. You know, it's really pared down. The form of the building is very simple. It's sufficient for what it does, and it enjoys that sufficiency. It enjoys that efficiency of the structure. So we really, you know, we let the wood do the work, is what our t-shirt says. And so this building was 2/3 pre-let before it finished. It was on budget and on time and cost equivalent to concrete. And when I see the client now, he gives me a hug, which is very nice. And now we're on site with our biggest project so far at the moment, which is in Milan. And that project, again, you know, not central Milan, on the outskirts of Milan. And so this project was also one really around for Lend-Lease and about efficiency. And so what we did was to work from the very beginning with the agents and with the developers for this building. And they were absolutely categorical that we had to have a 9 by 9 meter grid. And this is the perfect office space. So what we did was to design that first. So we designed this incredibly efficient structure for a 9 by 9 meter grid. Then we have the services running behind, which come into the grid here. And then we take that grid, we work it up through the building, we have prefabricated facade, and then across the building. And so the building will be complete in 10 months. So that's 23,000 square meters in 10 months. And inside, again, really simple finishes, open natural glazing, openable windows, clear glazing, and lots of exposed timber. And you can see again in the main foyer area. So this is the front of the building here, facing south. And we built this in Milan. We built this for the insurers. So we got the insurers and we got the estate agents and we brought them to this warehouse in Milan. You can see this is an insurer here. It's trying to push it over. Oh, it's quite strong. So, in fact, this is the guy here that gave us the insurance. And he actually charged the client less for this building than they would have done for a concrete building, because he said that so much care and attention had been taken over the detailing of the building that they weren't used to seeing that much care. And so they gave us actually a lower insurance. This is our latest project in London at the moment. This is a hybrid project. And again, one really about efficiency, about understanding what the job of the office is. You know, so this building here designed around a grid for steel and timber. And what we're doing here is we're using steel columns, but we're using gas pipes. So we're using a recycled steel content. So a gas pipe has to be plus or minus 1 millimeter. And so any gas pipes that are manufactured which don't quite meet that tolerance are rejected. And so we're using those as our columns in the building. And we set that out on a 24 meter by 6 meter grid. We put the core in the middle so that it efficiently works and feeds the office, like this. And then we set out that grid here using the timber there, a prefabricated facade, and then again stretch that up the building. And so then we have 45,000 square meters of office building, a 60% reduction in carbon over a typical central London office building. No basement, which is absolutely essential for carbon savings, and timber floor slabs. What we were able to work out with our client is actually in a typical office building, around 70% of the carbon is just the floor slab. And so rather than kind of thinking about the glamorous moves of the first building that we saw in terms of reducing carbon, the Bloomberg building, actually what this building does is it looks to identify what the key problems are and solve those. And so we take out the floor slabs and replace them with timber. We remove the basement. A basement is usually about 5 times more carbon intensive than a regular floor because of the amount of concrete that goes into a basement. And so we have this incredibly efficient building. We're working on the facade here, so the facade adapts as you go around the building. So the facade adapts as you go around the building, and we're using I'll probably hit something. Sorry. So we're using this facade material called UHPC, which is an ultra-high performance concrete, which means that our facade is about 35 millimeters thick. So an incredibly small amount. Thank you so much. So we're using really lightweight concrete to ensure that the amount of carbon is reduced, but also the weight onto the building is reduced. So this cladding material there allows us to have natural ventilation at the top. So that allows us to have natural ventilation at the top, and the facade slips onto the structure at each level. What else can I tell you about the building? Yeah, there you go. Perfect. So you can see inside that the module of the facade is the same as the internal structure, and so this hangs on the building from the outside. You can see each one of those modules there. For fuck's sake. So each one hanging on. In fact, I've never spoken about this building before. We just finished it. So we just finished the design. So this is appropriate. Do you want to stay with me? So what this building does really is to begin to talk about that kind of efficiency and sufficiency, and from gaining joy, from gaining an architectural success by an understanding of how that building feels to be in. You know that we have, you can see here, we've got natural ventilation which is drawn through the facade in every bay. So all the systems just sit within the first bay of the building. And so this really kind of pared back facade, this pared back building. You can see here's the entrance and the core rising up here. Now, one of the things that we think about quite a lot in the practice is the buildings that are already there, because obviously the building with the lowest carbon is the building that already exists. And so this is obviously Manhattan. The average age of a tall building in Manhattan now is about 60 years old. And so those buildings are reaching the end of their life in terms of how they're working, in terms of the materials and the exterior of the building. And so what we can do with those buildings, I think in timber, is a really interesting proposition. We've worked on a project of similar height in London, so a 38-story office building from 1968 in central London, and looking at how we can add a timber structure to the outside of that building and on top of that building without changing the foundations. So because the loading on the buildings now is a lot less than it was 50 years ago, because 50 years ago you had filing cabinets and paper, big heavy desks and lots of people, and now buildings require a lot less in terms of loading. So actually we can increase the area by a third without having to touch the foundations and without having to change the lifts. So that's that building finished, and you can see that every 6 stories we have this kind of open deck area within the building to bring in fresh air. This is a building in France, a laboratory building in France, and here what we're doing is beginning to use other bio-based technologies as well. well. So on the ground floor, we have rammed earth walls on the ground floor. This is the second time that we've used rammed earth, and this will come from the local area. And this again is about celebrating kind of like the lightweight nature of the material, the transparency of the glass. This is the north facade, and you can see straight through the building into the rest of the building. So it's about an architecture which is really open. So you can see here we have a public courtyard, we then have a courtyard for people that work in the building, and that kind of like flow through the building is about a very open, a very accessible architecture. Through there you can see, with the round earth walls on either side. Yeah, it's very exciting. This is a project we did a while ago. This is our only built project in Spain, so I thought I'd talk to you about it. So the Americans have a problem, several problems, but this is one of them, which is that they have a tree called the tulip tree, and the tulip tree has a very small root ball. And the sad thing is because of climate change and the increase in wind speeds, they've nearly all blown over in America. And so they have big warehouses full of this high quality hardwood called tulip wood. And so they sent us some in a pallet, in a shipping container, and they gave us a little bit of money, and they said, what can you do with this? And so we began thinking about how we could talk about the work that we were doing and to use the material to try and access a wider public, to try and talk to people about opportunities of building in timber, of modular, of prefabrication. And so we approached the big museum in central London about having a display there. We took the timber to Scotland and we made our own CLT, which is a really excellent, exciting thing to do. This is Neil and Sean, and we made our own CLT. So these are the boxes from the model, and they became the boxes in real life. And you can see how strong this is. So this is, I think the loading is 4 people per meter square, and the CLT is 70 millimeters thick. So incredibly strong. And then we took that and we built these boxes and piled them up at the Victoria and Albert Museum in central London. And people took their children there and then ran away, left their children. And then we took it down and we put it up in Milan, and then we took it down and we put it up in Madrid. And we took it down, we put it up in Glasgow, and then we took it down and we put it back up in London, and we're just waiting for the next place at the moment. So this is in Madrid. You can see even the king is watching there. So about 20% of our turnover as a practice is pure research, and we work for a number of different organisations in research. We have 2 Horizon projects at the moment with the European government. This one is a building wood system, and the idea with this is to take all the different regulations across the EU, +1 in the UK, and take all the different regulations and to look at how we can actually build a system within those regulations, about how we can understand how the process of design, the process of manufacture, and the process of construction can be unified through regulation across Europe. And so this system design works within all the different building regulations, and is a parametric design which will be available open source later this year, online and in buildwood.com. And so we have 7 pilot projects working with this system across Europe. Some of them are new buildings, some of them are on top of existing buildings. And then they will be available, as I say, in 3 different system guides towards October this year. And in the UK, we're working on a system for providing safe and robust housing. So, after Grenfell in the UK, there was a serious amount of worry about building in timber because of fire. And so we worked with the insurers, we worked with policy people, with local government, with building code officials, fire engineers, structural engineers, for 3 years actually on this project. And so what we did was to propose 25 standard details, which any architect can use, any builder, contractor, house builder can use. And these 25 details provide a robust method of building in timber. So that if you build like this, and it doesn't determine the plan, and it doesn't determine the facade, So you can use these buildings in lots of different forms with lots of different plans. But what it does do is every time that there's a junction on this generic building, that junction is described and it's pre-approved. So if you build it like this, you know that you will get approval from the city, from the fire brigade, etc. So this is some of those details here. And then each one of the details has a checklist. And then each one of those is published in a guide and with the details and the evidence that backs up each one of those details. So, these are some of the projects we're building with those details, or designing with those details. And essentially what it allows us to do is to reduce the carbon of new housing by 75%. So this is why it's so important to do and so worthwhile doing. And this is the number of tree seeds that it took to grow the trees that built our first tall building. Thank you.
Thank you very much for this inspiring lecture and for sharing with us your experience and your vision on how to use timber in architecture. I think we have time for some questions. I don't know if anyone wants to ask anything to Mr. Wu.
Yeah, hi, my name is Diego. I know that you are one of the pioneers of timber construction in the UK. And I wanted to ask you, how has been your experience through pushing policymakers in order to improve the industry, not just in the UK, but in the European Union as well?
Not easy.
Yeah, I can imagine.
Not easy. I think that in the UK it's perhaps more difficult because we don't have very many trees. So we don't have very much help. I think in a country, if you look at Germany or Austria or Sweden, Norway, Finland, Spain, countries with more trees, it's definitely, you have more help and there's more interest there in the government. I think that the construction industry is such a massive industry. This is the biggest industry in Europe. And to go in and to say, we want to change this industry, makes people very unsettled. So it's a lot slower than I thought it would have been. I thought, oh, fantastic, I found the answer, But no, so it's slow, and but you know what? We have a lot of manufacturers now in Europe, a lot more expertise in Europe. I think there really is an understanding of the carbon implications of construction now. And as we get better at other things, construction becomes more exposed as one of the primary causes of greenhouse gas emissions. Thank you.
Can I continue?
Yeah, of course.
Sorry.
Yeah.
What do you think about taxing the carbon emissions, just like to play in the same ground?
I think it's inevitable. It will happen. Carbon taxes will come. In Ireland, they now have a tax on concrete, and I think that will become, increasingly an obvious thing to do. Because there has to be. I think that you need both. You need both incentives and legislation to back you up. So you need a carrot and a stick. And the industry is not going to change on its own. So it needs those incentives. We are seeing incentives we're seeing more incentive from investors, from capital funds, than we're seeing from government at the moment, which is crazy. So the investors have ESG funds, environmental and social governance funds, and they are looking for green buildings. So this is why Blackstone came to us, because Blackstone have carbon targets that they need to meet, and so they began to do that. There's no legislation that encourages them to build low carbon.
Thank you.
Okay. Any other questions?